Hey everybody, today we're going to talk about equivalent expressions using algebra tiles. So you can look online and find where they have algebra tiles. We're going to draw ours on today. If you want to use virtual manipulatives, you can, or if you want to use sticky notes instead of tiles, it's up to you. If you want to be able to move them around. So I'm going to use drawings. So each one of these is going to mean 1x. Each one of those is going to be one positive, so a positive 1, and then each minus is going to be a negative 1. So here I have to draw the expression 4x plus 12. So if I model it, it'll be 4 of my x's. And since it's plus 12, it's positive, it's going to be 12 pluses. Now, if you're using manipulatives, you can kind of move these around to make your groupings. Otherwise, you're going to have to visualize how to do that. So we're going to try and find more than one way to group these. So they're already in one group. So how could I break them into two groups? Well, I have 4 x's, so I could put 2 x's in each group. So 2 x's and 2 x's. And then I'll think about how I could split up my pluses. Well, I have 12 of them. So if I split them in half, it's 6 and 6 pluses. So I could write it like that, or I can write it with parentheses. Parentheses just mean groups of. So 2 groups of 2x plus 6. That's another way to write it. And that makes sense because if I distribute this out, if I multiply through, 2 times 2x is 4x, and 2 times 6 is 12, which gives me my original expression. Now let's try to break it into 4 groups. Well, I have 4 x's, so I'll put an x in each group. How can I break up my pluses into 4 groups? Well, 3 can go in each group. And so another way then that I can write that is I have 4 groups of x plus 3. And if I multiply through, it makes sense. 4x plus 12. One group, well, that's what I have here, so I can show it this way. 4 x's plus 12 of my pluses. Now I have to make one group and 3 other groups. Let's make these 3 other groups equal. So think about how I can make 3 equal groups, and then I'll just have a group of leftovers. Our groups don't always have to be equal. They can be, but they don't have to be. So if I look at 3 equal groups, I know each group is going to have 1 x in it. I don't have enough to put 2 x's in each group. And then the greatest amount of plus signs that I can, positives I can put in each group is 4. And that uses all my positives. But I have 1 x here left over. So I'm going to add that on down here. So I could write this as 3 groups of x plus 4 plus x. That'd be another way to write that expression. And there are many more ways to write these expressions. You could even write it all out like this: x plus x plus x plus x plus 6 plus 6. You could do each individual one if you wanted to. You could do x plus x plus x plus x plus 1 plus 1 plus 1 plus 1 12 different times, and that would be an equivalent expression as well. So I'll work through a couple more examples with you. So here I have 2x minus 6. Now we're using minus tiles, but that's the same thing as the addition, just a different sign. So I'll draw those. Now first think about if I can put them into equal groups, and I've drawn them into equal groups actually here. So I have two groups, and in each group I have x and then minus 3. So I can check that expression down here and make sure that it equals my original expression. If I distribute, 2 times x is 2x. Bring over my minus sign, 2 times 3 is 6, so that works. I can also write it as x minus 3 plus x minus 3. And then if I want to check that, I can just combine my like terms. X and x is 2x, and then minus 3 gives me minus 6. So that works for that one. For my next one, if I want to model it, 3 x's and 3 pluses. So I could say I have 3 groups of x plus 1. And if I check that down here, multiply through, I get 3x plus 3, so that's correct. I could say I have 2x plus x plus 2 plus 1. That works as well. If I take it down here and I combine my like terms, I know 2x plus x is 3x, and 2 plus 1 is 3, so that works. Now go ahead and pause the video and try 3 and 4 on your own and then come back. All right, so 10x minus 15, I would draw 10 x's. And then 15 minus. I've already kind of drawn them in equal groups, so I could say I have 5 groups here of 2x minus 3 in each group. I could say I have something like 5x plus 5x minus 5 minus 10. That would work as well. And then as long as you checked your expression down below, that's fine. For this one, I would draw my x's. I'd have 6 of them. And then minus 5 minuses. Now this one I can't make exactly equal groups, but I can make some equal groups. So if I look here, I can make 5 equal groups of x minus 1, and then I've got just an extra x, so that would work. And if I distribute that one out to check it, I get 5x minus 5 plus x, which is 6x minus 5. I could write this as 3x plus 3x minus 4 minus 1. There are many different ways I can write these. And so that's how you write equivalent expressions with algebra tiles.